I'm so excited to see you all here at the Cisco Live San Diego 2025. How many of you all are brand new to network automation? Can you please raise your hand? Okay, great. The only hurdle when you want to learn anything new is to take that first step, and you all have taken that first step by coming to today's session. Okay? My primary goal for today's presentation is to make sure to educate you and to give you a tailored approach which can help you get an accelerated start in commencing your network automation journey with ease. And whether you are in a technical role or in a business or management role, I promise you will find yourself relevant in any network automation conversation after this session. My name is Siddesh Nayak. I am an architect part of Cisco CX. I have been supporting major service provider customers. I'm in this industry, networking industry, for close to 2 decades. And I am currently working with web-scale customers in their Sonic adoption journey. A few housekeeping items. I strongly encourage you to post any questions in the WebEx app because I have just 45 minutes. I'm trying to squeeze the demo as well, and I have tried to squeeze in a lot of contents for you all. And I'll also be available for the Meet the Engineers sessions with you all. And if you have any, to drill down anything more, I'll be available for questions for that as well, okay? And also, I'll be able to talk after the session as well. So don't worry, make sure you put your questions there so that I can finish my presentation on time. So today we will be learning automation essentials, core concepts, data encoding formats, Yang modeling, netconf, restconf, REST APIs, how to check in your code using Git, and I'll be navigating you all through the Cisco DevNet documentation usage. Okay. So when an user application wants to interact with a networking device, either it can interact directly, like you're seeing in this example, or this is called as device level programmability, or we can use a middleman kind of a concept where there's something called as controller or orchestrator, which will facilitate the bidirectional communication between the user application and the networking device. So that is called as controller level programmability. Typical examples can include your Catalyst Center dashboards, your Nexus dashboards, your NSO, network service orchestrators, and so on. So now let's take a look at the key automation components. The first component is the network application layer. So this is the layer which has all the applications which are programmatically capable to interact with the networking devices. The second component is the network devices layer itself. In this layer, the software running on the networking devices are having the capability to interact with the application layer. And the communication between the application layer and the devices layer is facilitated by the network API layer, which is having the protocols netconf, restconf, gRPC, etc. And to understand the word API in a nutshell, you just take A and PI, split it, and read it from right to left, programmable interface, which allows the access to the application. And if you want to recollect the whole presentation, what I'm teaching you, you just need to remember these things. We need a common language, a standard encoding format, and identify each other is authentication. So if you have these 3 things, you can make network automation possible. And that's what we are covering in each part. So whenever a user application wants to communicate with a networking device, or for any communication in general, the main requirement is having a common language and a script or a format which both the communicating entities can understand. Using the same principle for network automation, the common language used is netconf, restconf, and gRPC between the application and the devices. And the standard encoding format, data encoding format, which both the communicating entities can understand, is XML, JSON, and YAML. Since this is an intro session, I try to cover a few of the Python essentials so that people who are totally unaware of Python shouldn't feel lost during the session. So if you all are knowing Python already, then you can just relax. The main data types which are important for the network automation in Python are list and dictionary. List is like the grocery list your wife gives to you. It's just a collection of elements, and each element of the list is represented, is identified by indexing. In this example, the first element is identified by index 0, second element by index 1, and so on. And in this example of the code snippet, we are having the Python list data type, and we are having it saved in the devices versions variable. And we are trying to print the first element, the second element, by using the indexes 0 and indexes 1 respectively. The second data type is dictionary. Dictionary, like the literal meaning says, you have a word and you have a meaning. In Python, it's like a collection of key and value pairs, and it's enclosed in curly braces. For example, in this one, name is the key, value is Siddesh, age is the key, value is 18. Of course, I'm 18, you should trust me. And in this code snippet, we are having the dictionary data type, which is saved in the variable employee. And we are trying to print the name and the age of the employee by passing the key as name and passing the age as, the key. And it's printing Siddesh and 18, which are the values. So similar to the library is like collection of books. In Python, the library is like a collection of reusable code. And we have open source libraries and we have custom libraries. The important open source libraries used in network automation are NetMiko and NAPALM. And there is Paramiko, but Paramiko is not just specific for network automation, so I just excluded that. And custom libraries are the ones which your organization, people in your organization, put it in a library to you to reuse it. Welcome, sir. And library is a collection of modules and packages. So what is a module? A module is like a single file which has a list of functionalities defined inside that. And packages is like a folder which has a collection of modules. If you want to import a module inside the Python, you need to just give import followed by the module name. But in this example, we are trying to import a specific class connect handler from the module name NetMiko. So in the second example, we are trying to import a class name called data parser, which is present in the module name protocol, and which is present in the package name network_utils. So just like in the App Store, you have the App Store to download the apps. In Python, we have something called as PyPy, or Python package management. Here you can download the modules to reuse from this location. And pip is the utility you can use to download those modules. The basic commands needed are like pip search for you to search if the module exists already in your environment, pip install to install the package, pip upgrade to upgrade if you are already having that package to the latest versions, and pip uninstall to uninstall. It's self-explanatory. Pip list will give you all the list of packages which installed in your Python environment. And pip freeze if you want to save the modules installed into a text file for reusing in the future. You can use pip freeze and save it in the text file. So the next is the important component of serialization and deserialization of data. It's an important basic here. Whenever we have a Python application makes an API request to a networking device, the data has been, the data is represented as the Python object by the Python application has to be converted into string of bytes. Why? The data which is put on the wire should always be going in the bytes. So this process of converting the Python data object from the Python data object to the string of bytes is called serialization. When the Python application receives an API response, the API response also has to traverse the physical medium as the string of bytes. Now when the Python application receives it, for it to be able to interpret that data, the string of byte has to again be converted back into the Python object. So this process is called as deserialization. Okay. So let's take an example of how serialization is implemented. In this example, we are having the dictionary saved in a variable called device_inventory. The type function reveals the type of the data type stored in a variable. You can see it's dictionary. Now, when we perform serialization using JSON.dumps function, we can see the data type is now converted into string of bytes. So we have to do this for API request and API response. Okay. And we have different inbuilt functions in Python for performing serialization and deserialization. The example I showed you all was for the JSON, but you all can have XML, you all can have other data formats. You have different inbuilt functions which are put in this slide. You all can use it for your offline references. So I'm just flashing this. I'm not, so that you can just come to your mind. Okay, now let's understand the different data encoding formats which we are using for network automation. The first one being JSON. JSON stands for JavaScript Object Notation. Initially, it was designed for Java, but now it's popular in network automation as well. JSON data can be represented in two forms of data types. One is list and dictionary. That's the reason I tried to cover this in the Python Essentials. In this example, we are having the example of a list and a dictionary. I'll just try to double click on the list type here to explain you all. In this example, we are having the JSON data type, which is of form list. And list, we are having two elements here, which is device 1 and device 2. And device 1 is at index 0, device 2 is at index 1. And this is the start of the list, and this is the end of your list. And if you see, the element at index 0 is again a dictionary, so which means it's a key-value pair. Okay, and the key is device 1 here, and the value is again a dictionary. So again, it's a list of key-value pairs. In this, the keys are name, and the values are IP address. So you can see how complicated the JSON structure can look like. So you all should be able to understand how to extract the data once you get the API, once you get this data from the API response. Okay, so I am given this as an exercise for you all. You all should go and try this and try to find the IP address from the device. Okay. All right, so the next one is XML, which is Extended Markup Language. XML uses tags to describe the elements, and XML documents are designed using a tree-like structure. Hence, it's also called as element tree. And if there is a tree, there has to be a root, right? And root is the top element in any XML document. In this example, inventory is our root element, and anything above the root is called as prologue. And the first line of the XML document is always called as declaration. It is to tell the system that, hey, this file is an XML file. And the second line, I'm showing how to insert comments in an XML file. You should use an exclamation followed by double dash. And root element is like a parent, so it can have a child element and it can have multiple subchild elements to form that tree-like structure. And XML also supports, allows attribute within the tags. If you are seeing that, if you are using the tags attributes, the tag self-close here, okay? And in this example, name is the attribute, permission is the attribute, and so on. So this is how we deserialize the data when we receive XML in the API response. That's why serialization and deserialization is so important. The next one is YAML. YAML ain't a markup language. It's a nested abbreviation. The reason for that is it's just to indicate that it should be used as a data file and not like an XML document file. It's pretty much similar to JSON, so I tried to compare it for you all with the JSON example so that you all can resonate it. In the first example, and the YAML file always starts with triple dash, which is called as a document separator, and document separator, and indentation is very important in YAML. The spacings should be symmetric when you're having the nesting. So second example, you can see this is the example for list. List is represented as a dash followed by a space followed by the name of the list element. Okay, so space is important. And in the third example, we are having the nested dictionary. So you all can see that how easy is it to represent nested dictionary in YAML compared to JSON, right? So many braces and stuff. But the main thing is you should have this indentation very symmetric. Here we are using 2 space, that's the recommended one. And you all can see how to serialize the data when you receive an YAML data file from the API, in the API response. So this is the summary of just the use case. Usually the XML is used when we are using netconf protocol for network automation. The JSON when we are using REST APIs, and YAML is usually used for configuration management whenever we are using Ansible to configure the networking devices. Okay. Okay, now let's see how to use this data encoding formats to be in compliant with something called as Yang model. So before understanding what a Yang model is, let's understand what a data model is. Let's take a look at this example. Consider that this is me, okay? And if you want to describe me in this data model, how will you describe? You can describe me by my name, by my age, if I'm alive or not, etc., right? But you should see that there's a constraint here. The age has to be a number, the name has to be a string, right? You cannot call me 100 unless I'm a prisoner, okay? So the same thing is the constraint, the restrictions, those things are the parameters which will be modeling the configuration and operational data as well. If you see the networking example, I try to put Siddesh here. And it's throwing error because the configuration is not complying with the interface data model design. That's why it gives that error, okay? So Yang model is basically defines the design structure for modeling your configuration and operational data, which is strictly followed by the data encoding formats, XML, JSON, YAML, and transported by netconf, restconf protocols. It is defined in RFC 6020. And we have different types of Yang models, defined design for Yang models. Can broadly classified as industry standard and vendor specific. In industry standard, we have IETF, OpenConfig. In vendor specific, we have for Cisco, ISXE, ISXR, NXOS, and so on. So now let's see, take an example as to how these different types of Yang models compare. In this example, I'm trying to represent the interface properties using the Yang model defined for OpenConfig and ISXE native. You can see on the ISXE native and the OpenConfig Yang model, we are having the same information for the IP addresses. But the additional information on OpenConfig is it also has the operational state data, which is not present in the ISXE native Yang model. And also the proprietary configurations like MOP, the auto negotiation is not present in the OpenConfig model. If we compare the same with the IETF Yang model, now we can see that, I'm sorry, I'll just, and if we compare the same with the IETF Yang model, we are seeing that the configuration information for IP address is the same in both the models, but what happened? Same, but it doesn't have the proprietary information like the auto negotiation and the MOP. But if you compare the same thing with the CLI configuration, we can see there's an apple-to-apple mapping of the information configured in the CLI to the information configured in the ISXE native model. So now the question is, how do we decide which model to use? So I would say you can use 3 parameters to consider while choosing a Yang model for your organization. The first one is the automation tooling support you all have. The second one is the percentage mix of vendor devices you all have. And the third one is the core software features which are deployed in your organization. So based on these 3 parameters, you all can choose the Yang model which is appropriate for your organization. So I would definitely encourage you all to go and clone this from the GitHub and try to explore these Yang models using the tools I'm going to teach you all in the next slides. So like CLI, to get the proficiency in CLI, we need to know how to configure a feature. The same way, in order to understand the Yang structure defined, we need tools which can help us visualize the Yang structure designs. Okay, and a few of the important tools to have in your Yang tool racks are Yang validators, which is used to validate your data encoding formats against the Yang model design. The Yang code generators, which can automatically generate the code for you for the data encoding formats for network automation. The translators, which can translate between your different type of Yang model designs, which I just discussed. And I'll be covering 2 tools today as part of Yang tooling. And the first one is our very own Cisco's Yang suite. This is the amazing tool designed by Cisco, designed for Yang, and it can perform your code generation, translation, validation, and you all can build and test REST-based API and netconf-based API, and also you all can use this to validate all of your Yang models. And this is available on GitHub for free. Download it, explore it, and I'll be using the same tool to show in the demo as well. The second is the open source tool called PyYang, and PyYang is PyYang uses PyYang is also used for same purpose. In this example, we are seeing the tree in the output format, -p is for the path, and Yang model, and this is where you put the Yang model name. And we are trying to explore the IETF Yang model using PyYang here. The tree depth is an optional parameter which will tell you if which will restrict the output to a defined depth. It is very useful in making the output readable and specific to your needs. Once we execute the CLI, we can see that IETF Yang model is displayed in the in the tree format to the node levels which was defined by the tree depth. So we are having at node level 1, node level 2, node level 3. but the statistic is not getting displayed here because it's at node level 4, and our tree depth is set to 3. Okay. So you can also use to see this in the Yang model in the web browser by just piping the output to an HTML file and open that file in the web browser. So now let's see how to use the netconf, restconf automation, netconf automation with network automation with netconf and restconf. So the structured format used by netconf is XML, and the structured format used by the restconf is XML or JSON. So netconf uses SSH to transport SSH as the transport, hence it uses port TCP port 830. Netconf uses the concept of RPC or remote procedure calls. What that means is if an application running netconf client, it will consider the operations it is performing on the networking device as its extended function, which is running on the device's netconf server. Okay. Hence, netconf can also perform concurrent RPC operations on the devices. Hence, netconf uses message ID to track the RPC responses. The RPC defined for performing configuration operation using netconfs are edit config, which can have attributes like create, replace, merge, and delete. The RPC is defined for retrieving the configuration data is get config in netconf, and the RPC defined for retrieving the operational data is get. Similarly, for restconf, the configuration operation defined for performing the the API is defined for performing the configuration operation are post, put, patch, and delete, and the API which is defined for retrieving the configuration and the operational data is get. So to understand the difference between post operation, put, and patch, post operation is used to perform a brand new configuration on the device, and if you try to perform the post operation and perform an existing configuration on the device, it will throw an error. Whereas put operation is used to replace the configuration on the device. So be very careful while performing the put operation, it will replace your configurations. And patch operation is to use to append any new changes to the existing configuration. And delete is self-explanatory. So netconf has an unique concept of data stores, which will allow you to store configuration at various stages, namely candidate data store, running data store, and the startup data store. Whenever a user wants to configure the device, in netconf the user has the operation to choose the data store in which he wants to save the configuration. It is always advised to lock the candidate data store and the running data store using the lock RPC available in netconf, and also advised to configure any of your new configurations into your candidate data store first. So once the user executes the commit RPC available in netconf, the configuration will be moved from the candidate data store to the running data store. And if you want to retrieve any of the configs from any of these stores, you can use the regular get config RPC available in netconf. So this is an important slide. This will show what is the message encoding format, the operations, and the transport required when you are using netconf versus restconf. And this is the format we will be using to build the automation code. So this is an important slide for you. So on the CLI side, we need to enable a few configurations to enable netconf and restconf. I'm not going to read through this, but the important point here is for iOS XE, we need to configure the user privilege level to be 15. Otherwise, your netconf sessions will not come up. Similarly, for iOS XR, you need to configure crypto keys, and you have to mandatorily install MGBL and K9sec packages on the iOS XR. And we do not support restconf on iOS XR. For Nexus OS, it's pretty simple. Enable the feature restconf and allow the ports 80 and 443 for the NX API. And 443 is the protocol designated for restconf. You remember I had told Yang translators as one of the tools to be in your tool rack. On Cisco devices, we have an inbuilt utility which can perform the translation of your CLI to the Yang data encoded formats. And here is some of the CLIs which can do that. I'm not going to read through that one. But I'd like to mention that for iOS XE, we don't support the CLI to Yang translation for operational data. But for iOS XR and Nexus OS, we are having that option. Nexus OS, we have something called as XMLin, where you have to go into this utility and configure the CLI in a normal way. and then when you execute the show CLI, the output will come in the XML format. How cool is that, right? So this is the first CLI you all have to use to understand the correlation between CLI and the Yang. It's very easy, doesn't need any extra effort. Okay, demo flow. So I'm going to show you the demo using Yang Suite, and we'll try to configure the BGP neighbors on the devices using netconf. And I'll show you a RESTconf demo where we'll try to get the routing table information from the networking device. Okay, let's see the demo now. So this is the UI of the Yang Suite, and this is the device. We are seeing like there is no BGP configuration now, okay, and we will see after we execute the configurations, we'll be able to see the BGP configuration. So the main thing which you need to do is you have to set the device profile and give the IP addresses of the device you want to connect. You need to download the Yang modules from the Yang repository and choose the Yang module design you want to use for the communication. I have already created the Yang repository, but you need to just go and click on new repository, give some name, and create repository, and go to netconf and select the device to import the device, or you can also download the Yang module from the Git and click on get schema list. So then you will get the schema, and you have to click on select all and then download schema. I'm not going to do that as it takes a couple of minutes, but I have already set that up. Similarly, then you need to find the Yang model design which you want to do. Click on Yang set and create some Yang set name, and here it will display all the Yang modules which you Yang repository which you downloaded in the previous step, and then you can select whichever you want. In my case, we chose the ISXE native, so I'll come here and give native, and we will get a native model and which we will populate. Okay, so I have also already done that, so I'll be showing it to you all. So on the device setup, you need to just come here, and I'll show you what I have done. Just configure the IP address and the username and password. Then you have to just check the netconf box here, skip the SSH key validation, and check the RESTconf box here, check the SSH box here. That's it. IP address, password, username. That's it. And then you should click on check connectivity. I have already configured the configs required for enabling netconf on the devices. So you all also have to do that. And once you click on check connectivity, you will see this green check marks. If this means that the Yang Suite is able to have the netconf communication, RESTconf communication with the devices. After this, click on save changes. You will get your device profile saved in something like this. Okay. Now we have everything. Let's go and try to configure the netconf. Just remember the concepts which I had taught you, and we'll go exactly follow and understand and visualize that. The first is the Yang set, which is the Yang design which I had talked about. Here we are using ISXE native Yang model. So click on search for native and click on load modules. Okay. So once we are trying to configure the device here, so we need to select the operation which we want to perform, right? And for that we need to select the operation here, which is the edit config, and we need to select the device on which we want to perform the device. The device will be loading here. So once the device loads, we need to, I had talked to you about the candidate store and the data stores, right? So we need to go here and choose candidate as a data store, and also allow it to commit, run the commit RPC once the candidate configuration is successful. So now let's try to configure the BGP. We know that BGP CLI starts with router BGP, right? So go and find router here. Okay, I can see router. I'll click on this drop down. Then I'll click on BGP. And the key which you are seeing here, right? This is the mandatory key. Without this, your RPC won't be successful. So BGP ID is the mandatory key. I'll give the autonomous system number. Next, we'll try to configure the neighbor parameters. Again, the key is mandatory field here. My neighbor which I have configured is 2020-2020. The remote AS is 100. We are configuring IBGP. Now we'll configure the update source loopback 0. The interface is loopback. Just scroll down, find the interface loopback. Click on loopback. My loopback which I have configured is 10. Then the last thing which is required is to configure the neighbors and associate with the address family. So I am configuring the IP for unicast neighbors here. Again, here the address family is a key. So I'll select unicast. Then we will just go to unicast and configure the neighbor inside that. We will again give the neighbor ID, it's a mandatory parameter, and we will activate the neighbor. Okay. So now when we click on build RPC, you can see how beautifully the RPC is created. This is your XML data encoding format which netconf will be carrying. You can see the message ID which I had spoken about, the candidate data store, okay, and your commit RPC. So now the moment we hit run RPC, it will open another window and it will start configuring the BGP configuration on the device. Yeah. You have an option to switch over to show your CLI? Yes, there is. Yeah, that's a different option which is available here. That's a different way. You can put that RPC and it will show you the translation. Yeah. So now we can see the RPC was successful, okay, because this came as OK, and also the commit RPC came OK, and this was our initial edit config RPC. This is also OK. Commit RPC is also OK. So now let's go back into the device and check. We didn't have the BGP configuration before. It's giving us an OK, telling us that the syntax is correct. No, it says that the RPC communicated with the device and it configured it fine. Yeah. So if it has configured fine, now we need to see the configuration. Yes, we are seeing the BGP configuration, and if we see the neighborship, we can see it is established, okay, because the other device I had already configured for the demo. Now let's take a look how to retrieve the demo for the RESTconf, how to retrieve a routing table information using RESTconf. Again, I'm using the ISXE native model design, and I'm selecting the device R1, and this is the tree depth which I was talking about. You can restrict the output to a defined depth which you want to view. And once you click on load modules, okay, you can see it loaded, and we know that IP route is the command, right? So I will search for IP, and then I'll search for route, okay, and I'll go inside this, and this is where I have the IP route information. So once I choose this node and click on generate API, it will automatically generate the API, and it will we want to retrieve the operation, so we will go to get functionality here. First we need to authorize, which is we need to authenticate with the device, so we'll give the username and password here, authorize. So once we authorize this, we'll come down and we'll click on try it out. So it's as simple as that. Now once I click on execute, it will go and fetch the routing table information using the REST API. Now we can see we have the forwarding information here, right? So if we go back and check this in the device, show IP route, you can see that we have the 2020-20 with the 10.1.1.4, the same information we have seen here. Okay, and another amazing thing which I forgot to show you all is the replace. See, if you click on generate Python script, it will automatically generate the Python script. It will automatically generate the playbook. It was the same for netconf as well. Sorry, I forgot to show you all in the flow. But this is the beauty of that. This is how it's easy to build your own network automation code. You need not be so proficient in coding in order to do that. Okay, now let's switch back to the slides. Oh wow. Oh shit. I'm sorry, there's something problem with the slide layout. Okay, now let's see how to build your first API code using REST API. What we so the REST API, since REST API uses HTTPS in its request, it follows the same format as the HTTP headers. To build a REST API call, we need 4 parameters. One is the GET, one is the URL, the headers, and the data encoding format. The URL is made up of 2 components. One is the host name and one is the API path. Host name is the device on which you perform the operation. API path will say, hey, go to this path and get the data which I want, or post the data which I want to. And header is represented as a dictionary. And header, you can see the one of the keys is except, and it says application/JSON, which indicates that, hey, if the payload is in this API request is a JSON format. And also in the content type application JSON, it says the same thing. It says, hey, in the API request, the data encoding format is of JSON. And XOR token is the key where you specify the token and you can authenticate with the networking device. And the final step is to push all of these changes into the to the request library present in the request method imported from the request library in Python and store it in an API response. The second portion is to decode the API response. Like I mentioned, we need to code 2 things here important: deserialization, which I have already covered, and the second is the status code. Status code is the method we need to call, which will tell the API was successful or not. So once we have these 2 blocks combined, you have your first REST API code ready to programmatically interact with your networking device. This is a very simple code, but if you accomplish this, you will feel very happy that you are able to do that with the understanding you all have. Now you want to check your code using Git. Okay, so when you are downloading any software from the CCO, what you are trying to do is you are having the files from the master branch which are published, which is stored in a location called as remote repository by the Git. In the same way, the software which is built by the software developer is stored in a location either in your laptop or in a local repository, or in a local server, which is referred to as local repository by your Git. The process which defines the journey of your code from the local repository until it moves to the master branch in the remote repository is what Git is all about. So in the Git, you need to be aware of 2 taxonomies. One is the origin and one is the master. Origin is the default name which the Git uses to refer to the remote repository when you are in the local repository. Confused? It's like the origin is like the alias given for the URL of the remote repository. And master branch, like the name suggests, it is the master location which has all the latest changes available in the all the latest changes for all the software files of a software application. So whenever you want to make a changes, add a fix or a new feature, you have to pull the latest changes from the master branch. And once you make the changes, you have to push the changes back to the master branch. So in Git architecture, we have remote repository can be an on-prem or on the GitHub, and the local machine can be your Python application. And if we are trying to make a changes to the bgp.yaml file, the first thing we need to do is download the latest copy from the remote repository, and the command to use that is git clone, give the remote repository name. So once you have the file, after making the changes, you need to use git add, and that will push to the staging area, and then you need to execute the command git commit -m, and it will push the files to the remote repository. So the final step is to move the file from local repository to the remote repository. So that is done by using the command git push origin master. So read this command from right to left, which means that the changes which I have made, push it to the master branch in the remote repository. And what is remote repository represented as? Origin, right? So once you're done, your changes are now merged to the master branch in the remote repository. So for the Git branches, say if you have a team which is doing the bug fix and a team for fixing the new features, instead of pushing both the changes directly to the master branch, you can have a separate branch created, one for bug fix and one for new features. Okay, the command to create a new branch is called is git checkout -b followed by the branch name, and the star mark indicates Git has started tracking that branch. So once the changes are made, you can push the changes to the push the branch to the remote repository using the git push followed by the branch name. Now we can see there are 2 branches available in the remote repository, right? And your DevOps admin will now pull these changes and merge finally to the master branch. Okay. So I know this is a lot, but I tried to put the animations, so that at least you all can get the context when somebody talks to you about branching. Okay. So I have covered this one. The only thing which you need to do is you need to configure your username and associate with the Git application, and follow the steps I mentioned in the Git architecture. And from there we can, do the remaining things. Now let's see how to navigate the DevNet documentation. So the main thing what you all have to do is go to developer.cisco.com, and this is the amazing resource. Here the main thing is documentation, labs and sandbox. Documentation will give you all the documentation for the controller level programmability applications which I had discussed, like Catalyst Center, Nexus Dashboard, WebEx API, Meraki APIs, you name anything. Anything controller level programmability, all the APIs are in this location. Okay, so if I click on this, the way to search this is, don't put anything in the search bar, just click here and click on search, and then you will get all the filters here. Okay, so click on the, say for example, if you want to check the Catalyst Center, right? Just select the Catalyst Center here, and you can see all the resources here. Click on this one, go to API reference, and click on APIs. Now you can see all the APIs here, and also it gives you the Python code as well. So this is an amazing place where you can get all the API reference, build your Python code, everything. And the best one is the labs. Labs is the place where you can explore. Again, click on here, don't search anything, and click on search. Then come here and search whichever you want to search. For example, if you want to implement netconf, which we learned, right? Check ISXE, and you can see here we can have the explore the, and it has a step-by-step procedure to lab along with what you want to implement along with the devices. And the similar with the sandbox. For the sandbox, you will have the devices which you all can launch and reserve it. You will have the sandbox for all types of devices, including your dashboards. So just open these sandboxes. There are two types here. One is always on, one is reservable. You can use either of that and use it. Or for reservable, you have to reserve. For always on, you can go and just use it. This is basically very helpful for you when you want to do a demo, try to play around something and check something quickly. This is the awesome resource you have. So I think there's another tool called CMSE. I think we are just short of time. Maybe I can talk to you in the, that's an amazing tool. It's called Cisco Metric Search Engine. And we need to, I'll definitely encourage to check that as well. And I can show you all offline as well. So call to action, I have put some milestones for you all so that you all can follow this and follow this milestone in the next 24 hours. And I have given the step-by-step instructions. So if you implement this, you will find really value of whatever you learned today. You can use your learning labs, you can use the documentation, and it's very simple. Try this each milestone, and if you have any questions in the next 3 days, come back to me, okay? And I have put the references here for you all, for Yang Suite, for CCO documentation, and here we have the link for that CMSE or the Cisco Metric Search Engine. Explore that, it's awesome for your network automation. It makes your network automation journey so easy, okay? And yes, the final thing is session surveys. Please, please, please complete your session surveys. It's important for me as a speaker and can help me get points to bring more sessions to you all in the upcoming Cisco Live sessions. And I truly appreciate all your support here. And there was some hiccup in this slide change, so I thought I lost 2 minutes or something. Sorry about that. There's some glitch here on the desktop. But yeah, it's good that we tried to cover most of the things, and yeah. So I think we have just 50 seconds left for questions, but I am available here. You can book the Meet the Engineer sessions as well to discuss anything one-to-one with me. I can show you all additional stuff as well. So thank you for all your support, for understanding and helping me finish on time. And this is really great. Thank you.